Welcome to another lecture on standard costing. We will be looking at a problem that deals with fixed and variable overhead. We're going to be looking at problem 7.56 today. So 7.56 deals with or has some elements in it for direct material, direct labor that will be done in a fairly simple way. And then, as just practice. And then the main topic is the variable and fixed overhead. That's what I'll focus on today. So, first step is, for you actually, the best thing for you to do right now is stop this recording and turn to 7.56 and you do the first three lines. The first three lines are for chocolate wrapping paper and direct labor cost. If you consider, like I said, the best thing for you to do is right now stop this on your piece of paper, look at the book, get out the data and just say, okay, I'm going to do the first three lines. Then once you've tried that, check your solution, or I'll have the solution here and just, what I'm going to do is go over and get the solution and walk it around. I'll talk about it for a minute. Then we'll get into what we're really focused on today, which is the fixed and variable overhead, which is a very significant issue. Okay? So here I'm coming. Hopefully you have done this on your own, but maybe not. So here is the solution you would come up with for fixed and variable overhead. I'm going to review the pieces of it right now. Of course, you're going to have a title. If you don't have a title, that means that you've deliberately chosen to not do the quality work you need on the exam in your practice, which means it's going to be harder to remember this and to do it well on the exam if you're not actually practicing it. So now we'll move on to the different lines. So here the layout is the inputs like I had in that prior example. Standard price times standard quantity equals standard cost. All of these are fairly easy, although not totally easy. You're going to find you'll get stumped with this one. This one does not have a loss rate in it. Remember we focused on realization rate? The realization rate in this one is 1. There is no realization rate. And you're going to have to read the text. It's a story problem to figure this out. You're going to have to chew on that for a minute. I'll let you do that. And you can do it, but when you first look at it, it's going to startle you. It's actually fairly simple, but you have to break through a box to see it. This one I'm going to go over a little bit more right now because it's an important piece of the entire rest of the problem. But this is the direct labor standard quantity to make one box of chocolate. If you notice, the units are all set up here. So my end unit for standard cost is I have to compute the standard cost in dollars of a 1 pound box of chocolate for this company. I don't know if you've said this out loud, but this is the Don't You Like It chocolate company. People who write textbooks are bored. They try and come up with names that, make them laugh, I guess. So units, dollars per 1 pound box of chocolate, and it has to be the same all the way down. Dollars per 1 pound box of chocolate, dollars per 1 pound box of chocolate. Then you can follow the units over. Always review the units first whenever you're reviewing. So this is dollars per 1 pound of chocolate, not 1 pound box of chocolate. Dollar per 1 pound of chocolate. This is pounds of chocolate per 1 pound box of chocolate. Okay, if we cancel pounds of chocolate, then we'll get dollars per 1 pound box, so the units reconcile correctly. So review that. This one's the one that's a little odd. This is the wrapping paper that's used inside the chocolate. This is a box of chocolate that has individually wrapped pieces of chocolate. So we're dealing with the wrappings of the chocolate that are inside there. Yeah, and yes, you would do this in any kind of production environment. And so what you have is 10 cents a sheet for the wrap. It's a big sheet. It gets cut up into little pieces. And then you have 6 sheets per 1 pound box. So 10 cents a sheet times 6 sheets per box is 60 cents, or actually $0.6 per 1 pound box. And direct labor, the last one. Boy, I don't know where they got $4 an hour for direct labor, but the accounting works fine. Times the 0.25 direct labor hours per 1 pound box. This one is a little bit tricky because there is a loss rate in there. And you have to read through the text to find it. It's not given to you in the same way the loss rate was given in the other problems. You have to focus on that just a little bit. And I will do it right here. So This is also a case where in this problem you're going to get stuck if you go, because At a certain point dealing with time, and this will happen in a lot of problems, you have to decide whether you're doing this problem in minutes or in hours, because you can't really flop back and forth. And I'll tell you what you almost always have to do is you look at this and say, okay, I have direct labor. Time is always going to be an issue. So my answer has to be dollars per 1 pound box. Okay. And over here, how do you buy labor? Dollars per direct labor hour. So that means the units here have to be direct labor hours per 1 pound box. Okay? Or you have to change this to say dollars per direct labor minute. If you want minutes up here, it's fine. You get full credit. It's still, everything is correct. But you have to change this to dollars per direct labor minute. Otherwise, this will not reconcile correctly. So that's another way that looking at the units will keep you from screwing up and using mixed units when you shouldn't. The data that the problem gives you is largely in minutes, and you will try to work this out in minutes. And yes, you can do that. It's easy to work this out in minutes, and you'll put the number of minutes per 1 pound box here. And then if you're not careful, you multiply it out and get some crazy answer. Because if you multiply minutes per 1 pound box times dollars per direct labor hour, you're not going to get this. And hopefully you notice that, because when you write the units down, you'll say, oh, wait a minute, I can't cancel this. You're going to have to go back and change one of the two, either this to dollars per direct labor minute, or you'll have to go back and change this to direct labor hours per minute. So basically what the situation is, I'm going to do this right here just quickly so you can see it. This is my scratch sheet. I have 12 minutes of value-added time to make a box of chocolate. With a little experience, you'll sort of remember, after the second time you work one of these problems, 12 minutes is 0.2 direct labor hours. This is where I make the conversion. Okay, so that's your first opportunity to convert, to say, oh, they told me 12 minutes. I'm not doing this minute thing. I'm converting everything instantly into direct labor hours, because I know from past problems that I need to end up in, or I don't need to. The easiest thing for my life is to end up in direct labor hours, not minutes. So that is equal to 0.2 DLH. That's the value added time. So that would be one. Then to figure out the realization rate or loss rate, they are giving you the number of lost minute, of the amount of lost time. They're giving in minutes also. So that is another, a different box here. They said it's 96 minutes of non-value added time during the day. So that includes the, the break and everything. It's the break plus other things. So what you need to do is say, well, okay, I'm paying for 8 hours, but I'm not, so I'm paying for 8 hours and the minutes associated with 8 hours, but I'm only getting part of it. The part I'm missing is the 96. So the 96 is the lost time. And how much am I getting? How much am I paying for in minutes? Well, you're paying for 8 times 60, or 480 minutes. So if you take 96 divided by 480, you get 0.2. So that is the loss rate. Okay, it's 0.2. Once you get those two things, you can figure this out pretty easily in hours, which is you can take the 0.2 direct labor hours divided by 1 minus the loss rate. Remember, you need to take the value added time, or the output, which is also the output specification simultaneously. You might want to jot that down. Value added time is, in almost all cases, the same thing as output specification. The output specification was a traditional way of talking about it. We started using the word value added a little bit later, but it's the same thing. And then we've also computed separately the loss rate, and we need to take the 0.2 direct labor hours divided by 1 minus the loss rate. So that would be the 0.2 DLH divided by 1 minus 0.2. And this is a percentage, a dimensionless number. And so that's going to be 0.2 divided by 0.8. Okay? And you're going to get 0.25. And I made a mistake. This is DLH per 1 pound box. DLH per 1 pound box. DLH per 1 pound box. This is the number that goes in there. So that's conceptually, there's no trick there. But, you know, you're expanding your expertise and you're having to read the text, read the words, and interpret them. Remember, one thing I said, which you know, more or less know, is that, you know, we do a lot of number things as accountants, but we almost never use numbers to get numbers. What we are is we are interpreters of text and interpreters of law and rules and policies. And we interpret that policy to derive what the number should be, but we almost never think about a number in order to get a number. Okay, that's pretty rare. And this is another example of that we had to examine the text in that problem and study it to determine what they were trying to tell us. And every problem is going to be set up a little differently. Why? They're trying to stretch your brain a little bit. They're trying to get you to see things from as many different ways as possible, breaking all different types of, you know, thinking boxes that you might have. Okay, so that brings us back to, or down to this section. So we've just reviewed the first part of problem 7.56. And now we need to work with the variable overhead, fixed overhead. Notice that I've put the answer, part of the answer here. When we get these things for variable overhead, we will get the variable overhead standard cost. When we get these things for fixed overhead, we'll get the fixed overhead standard cost. When we add that up, we will get this, the standard absorptive manufacturing cost. So this is all absorption costing because we're taking all costs and absorbing them into the product. So that's why it's called absorptive cost. And it's standard cost. So the standard cost per box is $6.8949 per 1 pound box of chocolate. There's another line we'll do after we get to this. So what I'm going to do is spin this around and work on how to get the numbers that we need for VOH and FOH. After I get them, I'll turn back, fill this in, talk about the standard absorptive manufacturing cost, and then I'll do the last line, which is the budget formula. So we need both this, okay, which is a cost that doesn't change. We will also have the budget formula that allows us to compute the costs at different production levels. So this is really, we call it SAMC. It's a form of average cost. So this would be like we don't use the word average, but this is an average cost that we expect. It's not the cost at any given time. It's averaged across the entire period. Okay? So now we need to take a couple of minutes and look at the data again and the methods and look at fixed and variable costs. So, first, we need to talk about the methods that we're going to use for a few minutes.